All right, let's solve some more radical equations. This time we're going to deal with the ones that have square roots on both sides. So no fractional exponents, just the square roots. So if I look at this first example that we have here, what am I going to have to do first? Usually I need to isolate the radical. Thing is, I actually have two of them. So the first thing I just start with is go ahead and square right away. So I'm going to go through, I'm going to square both sides. The nice thing with this, what happens when I square both sides? Well, I get rid of the radical, and all I'm left with is the radicand. Now, the radicand is actually just what's inside. So I don't square the stuff that's inside, I just bring it down for the ride. So now I've got a pretty, relatively simple example of, just algebra 1 now. So the only part that's really algebra 2 is to square both sides, so I get rid of these radicals. So subtract x from both sides. And when we do so, I'm left with only x over here minus 3 is equal to a positive 6. I got to isolate the x, so again, this is just right back to algebra 1. I'm just going to add 3 to both sides, and I end up with x equaling 9. And the nice thing is I can just go ahead and take these values, substitute them right back in, and figure out if I'm right or not. So 2 times 9, that's going to be 18. 18 minus 3, that's going to be 15. So up here I've got the square root of 15 so far. Now, if I come over here, substitute the 9 in, 9 plus 6 is 15. So, well, nicely, thankfully, happily, square root of 15 is equal to square root of 15. So, boom, I'm done. I got it right. All right, so let's take a look at this example over here then. Again, I want to isolate the radical. Well, I've got this 1/7 here. Well, I'm going to get rid of that 1/7. So what I'm going to do is I'm going to multiply both sides by 7. So I'm going to take this part that's over here, the 3, and I'm going to multiply that by 7. The idea is that we get rid of the fraction. So now I have 21 is equal to the square root of 260 minus x, and that's all underneath the square root symbol. Well, what do I need to do to both sides? Boom, square it. Go ahead and square this side too. So now I get 441 is equal to 260 minus x. And now I got to subtract 260 from both sides. I'm going to subtract 260 over here as well. All right, so now we just go ahead and subtract. You know what, let's do some old school subtraction. So I'm going to get 1 minus 0 is 1. I'm going to have to borrow from here. So now I've got an 8. And then over here I have a 1. So 181 is equal to a negative x. I don't care what negative x is. I want to know what x is. So x is equal to negative 181. The negative sign didn't quite come out. There we go. All right, so there's 2 more examples. So let's scroll down a little further. I added a couple more examples just like the ones that we did up above. So let's go ahead over here. We're just going to square both sides right away. So same thing that we did on the other examples above. Remember, when I square a square root, all I get is the radicand, which is what's inside. So I get 3x plus 3 is equal to 5x minus 1. I know that some of you like to go through and just make sure that you have, like in this case, that you would subtract 3x from both sides. It doesn't matter which way we go. Just as of my own training from way back in the day, I always like to have the x over here. So we have a negative 2x plus 3 is equal to negative 1. We have to subtract 3 from both sides now. So I get negative 2x is equal to a negative 4. I don't care what negative 2x is, I want to know what x is, so I've got to get rid of that negative 2. The way I do that is by dividing. So now, those are gone. X is equal to, well, negative divided by negative, that's going to give me positive. 4 divided by 2, that's 2. So we're done with that one. Again, take the value, substitute it up into here. So I take 2 times the 3, that's going to give me 6, plus 3 more, that's going to give me 9. Square root of 9 is 3. Take this 2, substitute it up into here. So I get 10. 10 minus 1, square root of 9 again. Perfect.